Our primary strategy for solving rational equations involves identifying the least common denominator, or LCD, of the rational expressions that are a part of the rational equation. In this example, we have two rational expressions that we need to worry about. The first is 8 over x minus 5, and the second is 3 over x. Examining those two individual denominators, we get a least common denominator of x times x minus 5. And this is the factor that we're going to use to eliminate the fractions from the equation and get us an equation that's a little bit easier to solve. This least common denominator is going to get multiplied by each one of those individual rational expressions and with the 1. When it multiplies by the 1, it will just create x times x minus 5. But when it multiplies by the two rational expressions, we're going to see a clear out of the fractions, creating an equation that's a little bit easier to solve. The second one, the second multiplication, the x minus 5 from this denominator will simplify out with the least common denominator multiplication, leaving us just with the 8 from the numerator and the x from the least common denominator. And then the same thing will happen on the other side. This x will simplify out with that x through the multiplication, leaving us with just the 3 and the x minus 5. With nowhere else to go and all the fractions gone, we're going to multiply out what we can and try to devise a strategy for solving. The presence of this x squared indicates to me that I'm going to want to push all of the terms to one side, set this polynomial equal to 0, hopefully factor it, and find solutions that way. If that x squared term wasn't there, I'd have a regular old linear equation that I could just solve using the same pre-algebra and algebra 1 techniques that we're used to using. But in this case, I'm going to have to go with the factoring and the solving instead of just the linear equation route. So pushing everybody to the left, we're going to simplify the left side. We're going to move the 3x over with those. That's a grand total of 16x. And then we're going to add the 15 over and get this entire thing set equal to 0. Our factorization, going to start with two x's. We're looking for numbers that multiply together to make 15, but add together to make negative 16. That's negative 15 and negative 1, meaning we're going to have solutions of 15 and 1. You want to get into the habit with a rational equation of always checking your answers. There's a few reasons that are highlighted on the lesson page as to why this will be of special concern for us. But you always want to check your solutions to make sure that they actually work and that they're not extraneous solutions that look like answers but really aren't. You want to make sure these numbers are in the domain of the function or the domain of the expressions and that they actually work. So we'll take our 1 back in and we'll check our 1. Start by checking our 1. So when x is equal to 1, we have 1 minus 8 over 1 minus 5 equals 3 over 1. This whole thing right here has a value of 2. 1 plus 2 is equal to 3, so that's good. And then if we check our 15, this one's a little bit trickier to check. 1 minus 8 over 15 minus 5 equals 3 over 15. 1 minus 8 over 10 is equal to 1/5 if we simplify that side. This is really 4/5. 1 minus 4/5 is 1/5, and that checks out as well. So we want to get into the habit, especially with rational equations, to check our answers, make sure they work. Not only just make sure we didn't make a mistake, it's a good habit to get into to check your answers anyway, but we want to make sure that they are actually parts of the domains of these individual rational expressions. On occasion, it's going to happen that it's not going to work, and we want to be able to identify those situations when they don't.